Of course, polar graphs don't live on their own. There are also the Cartesian graphs, i.e. rectangular graphs, that we had on a typical horizontal vertical axes. And any function we have could technically work in both coordinate systems. And those two graphs inform each other. So what do I mean by that? Well, let's look here. So I have this graph here and I have this graph here, and they're the same graph. They're the same function. But this is the graph r equals 3 sine of 2 theta, where this is the theta axis, this is the r axis. And it's graphed on a rectangular coordinate system. And this is graphed as a polar graph. So let me show you in Desmos what this looks like. All right, so as we graph in rectangular, right, those two black points are the same point. What's happening is that this one that's dotted, that's the rectangular graph, right? And then this one, of course, is the polar graph. So if I take it to the very tippy top of that peak, that takes it to the tippy top of that petal of the flower. And as it starts heading back, that point, right, as it heads down towards zero, that means that we're heading back to the pole. And then if I swing through to the green part, you see how it's happening, right? So the very, very bottom is when it's at the farthest end of that petal, right? So the loops on the polar graph correspond to the hills and valleys of the Cartesian graph. So the Cartesian graph and the polar graph are intimately connected. I mean, they're the same graph, but they're on two completely different graphing systems. Fun, huh? And you'll notice, by the way, that this particular graph has a period of 2 pi. So it's a period in a polar period, not necessarily a rectangular period. The rectangular period of the graph is pi, because by the time I'm done with the green portion, by the time I'm at pi, I've done a full peak and a full trough, right? A full hill and a full valley, and I'm done. But not so with the polar graph. For the polar graph, I need to go all the way around until I circuit through. And that doesn't happen until I'm after, well, this next section, once I'm after that fourth petal. And I'm saying petal on purpose. That's called a rose graph or a flower graph. And you can see why they called it that, because it looks like a flower. So they called those rose graphs. All right, so let me go back to our piece and note that just in a couple places. So for one thing, we could see that it was arrowing through. So it kind of goes like this. So it kind of comes through here. So that's section 1. That's why they numbered it 1. So this section right here in blue corresponds to this section right here in blue. And it cycles through. Then this section in green corresponds to this section. So it comes through the origin, the pole, and comes around, and it goes this way. Then it goes to the pink portion, right? So that hill is this petal, and it kind of comes through like that. And then the last portion, I don't know, it's kind of yellowy. I don't want to put my yellow highlighter there. Yellow highlighter probably won't do us any good. So let's go orange, right? And so the orange portion comes up and through like that. So the period in the polar coordinate system, so the period here is pi, but the period here is 2 pi. It took 2 pi to finish the full rows. All right, so now we see there's a connection between a Cartesian, which is another way of saying rectangular. Right? Cartesian is naming it after the person that thought of it, René Descartes, the French guy. So Cartesian and polar graphs connect to each other. All right, so let's keep up that connection down below for the next graph. So I have a Cartesian and polar graph of the function. Mark the points on the polar graph that correspond to the labeled points on the graph of the Cartesian. Oh, okay. So we've got some things going on here. So we can start off at the beginning, which is A. And I think this will go a lot easier if we look at it a little bit in Desmos first, because of course I have this graphed in Desmos, and it's right here. And I even have the points graphed, right? So point A is right here. You see it? It's where we start. So let me start at 0. Let me go back, right? So point A is right there, right? We start at 0 and we kind of move our way out. And we swing through to point B. Point B is going to be at the origin, right? It's going to kind of go through. And then C, look at C. C is the bottom of that little graph, right? Forget about the polar for a second. It's right there. There's point C, but that's where the petal is on there, right? So that little bottom part right there corresponds to the outermost portion of that petal. And I've color coded everything, so let's see if we can kind of match it. Okay, so point A is where we start. So point A is right out here. So there's A. And then we kind of swing through with pink. So this little portion of the graph right here corresponds to this little portion right here. B is actually the origin. B, D, F, H, those are all at the pole. So I can't put those all in there because it's right there, right? You're at 0, right? So notice the point B is at 0, so you're at 0. You're at the origin. Then C, so let me do this little bit in blue. That little bit in blue, see how it's kind of smaller? Corresponds to this little petal right here. And so that point C that's at the bottom right there is this point C that's there. A, by the way, is up here. B is right there. D is back at the origin again, so I can't do that. So B, D, I can actually tell you F, H, J, and L, because those are all the poles. So that doesn't really help us on anything. J and L. J and L are all the origin. Right, the pole. So they don't do us any good. Okay, so I'm not going to label all those because they're all the origin. All right, so next, what's my next section? Let's see here. I've got kind of this big portion right here. So that's going to go far out. And that corresponds to actually this big petal right here. So that point E right there is this point E right here. It's when you're out at the farthest point of the petal. And if you don't believe me, of course, I can show you. Right? It's right there. See how E, farthest point out? Let me go out. Boop, there it is, right? I didn't have yellow as an option in Desmos, so I did black, but you get the point. Okay, next. For my next portion, I'm going to go down underneath, so it's going to be another small petal, right? Big petals, big hills make big petals, and the little hills are going to make little petals. So this petal, so it swings through, and it comes down and it's going to go to G. So it's going to go out here. And G is the point that's right here. And then, let's see here. Let's do like a purple. So this big petal right here in purple, well, it's a big hill, is going to make a big petal. So I swung through G, so it's going to have to come out this way. And so that point I at the top, right? If this is E at the top, this is I at the top. That I is this out here, right? And I swear that petal is purple. It's not coming through. There we go. So I started at that little hill, or that little A, kind of swung through, went to the little C, came out to the big E, then down to the little G, then out to I, right? Then I have, I'm running out of colors. Let's do green. Right, so green down here for the last little petal, right? So that last little petal, that's got to be K right here, right there. And then back up to M. I'm just trying to think about my color choices. I'm running out of options. I kind of do it in a different color pink, so it's not as bright as the other one. So that's this portion right here. So M is right here. So let's see, I've got A, B, C, D, E, F, G, H, I, J, K, L is the pole, and M. I've got everything labeled. And of course I can show it to you in Desmos as well. One more time, because I know we've already looked at it. So I press play, you can see it cycling through. The dotted portion is the Cartesian portion, and they color coordinate. So if you're not colorblind, which hopefully you're not, you'll be able to connect them. But of course, even if you are, you can see right there, that's a big hill, so it makes a big petal. And then this next section, which I colored in green, is a little hill, so it makes a little loop, and so on. And there's another big hill. And then at the end of this, I'm back where I started, which means that the period is again 2 pi. It takes 2 pi to run through a full cycle of the rows. It doesn't take 2 pi to do the Cartesian, the hills and valleys. That we're with more quickly. But it does take 2 pi to do the full rows graph. And of course, this graph is available on the class notes page.